AI hardware doesn't care about your quarterly goals or your digital transformation strategy. It cares about physics. It cares about kilowatts per rack, coolant flow rates, and whether your raised floor is going to collapse under 3,000 pounds of silicon. More than 90% of enterprise data centers are not equipped to run the next generation of AI hardware. That's not a forecast. That's just where things stand right now. Which means that most organizations operating on the assumption that they can deploy AI workloads on premises, well, they're working with a plan that just doesn't hold up to physics.
WWT presents Research.
I'm Rob Boyd, and this is Worldwide Technology Presents Research. We're on Priority 3 of our data center series, AI Readiness. In our first episode, we talked about the aging foundation of the data center. Today, we're talking about what happens when you try to put a lightning bolt into that foundation. Chris is Senior Director of AI Solutions at Worldwide Technology, responsible for GPU clouds, co-location hosting, and facilities practice, everything from grid to chip within the data center. He sees how organizations approach AI infrastructure decisions, and he sees what happens when the excitement of new hardware outruns the planning.
In 2025, there was a lot of exciting announcements coming from, our biggest partners like NVIDIA, and one of those was around Blackwell. And Blackwell was something that the market was very excited about. It offers and still does amazing amount of compute power and performance that organizations need. The requirements for Blackwell are a little different than what the previous version had been. And so folks got excited about ordering the Blackwell, and they would, I call it stroke of the pen. Someone decides to order a super pod so they can get it, or a pod, and that pod lands at their data center on the dock. And they recognize that, well, maybe their existing infrastructure arrangement or their data center cannot actually hold and do liquid cooling, and it doesn't have the power that they need to the racks. And so they had to act quickly. And so, what I mean by stuff arriving on docks and them not being ready for it, I think the excitement of getting the latest and greatest equipment wasn't necessarily met with the planning to provide a data center to support it. And so what that really gave us was this conundrum, because you have this expensive gear sitting there. And in some cases, there was look for co-location providers to put it in, or other places. So it was an interesting thing to grab the equipment, but not necessarily be ready for it.
These aren't rookie mistakes. These are sophisticated enterprises. But AI has created a buy it now or lose your spot panic, right? The FOMO, a world where urgency to secure the chip is moving much faster than the ability to power the chip.
If you are a large financial organization or a life sciences research organization, you really want to be able to have the access to these incredible chips that NVIDIA is putting out. So if you're doing that and you're able to do that and grab them, then you want to. I just think that those investments that are made are sometimes done quickly, because the decisions have to be made quickly due to availability. And so you just don't check all the boxes from a readiness standpoint to make sure that you're prepared to put this stuff on site.
That availability constraint is real. This isn't like ordering servers where you can wait a quarter. This is equipment that may not be available again for months, maybe longer, and everybody knows it. And that urgency is arriving exactly when organizations are already stretched. AI spending is increasing, but the number one budget casualty is legacy infrastructure. You're simultaneously under pressure to innovate while the foundation is aging out. Chris has been in technology for 3 decades, so he's seen a few hype cycles. His read on this one is different.
There's a fair amount of people that move fast just due to the requirements of their business, whether it was their boards pushing them. It could have been a variety of things. The comment I make to most people is, we'd said 20% of the people are doing projects today. The thing I say to the other 80 is, if you haven't started with AI, it's okay, but you better get started tomorrow, because you're not too late. But this is not going away either. This is not a trend. There's not going to be a bubble. This is way too transformative a technology for it to get pushed aside.
20%. Well, Chris asked that question at every AI Day event WWT runs. San Jose, Dallas, New York, Atlanta, Toronto. Doesn't matter the city. About 20% of hands go up when he asks who has an active AI project. The other 80% are watching, waiting, trying to figure out how to move forward without making expensive mistakes, which brings us to to this framework?
There's a process that folks look at and our clients look at when they're determining their AI. It's very simple. You typically start with what's called a center of excellence, which is a cross-functional group that's going to make decisions on AI use cases, what you're going to decide, what you're going to do. They will then pick a use case or more, and then they will, pursue that use case, look at the data around it, pick a model to run it on, and then, determine some type of architecture to run it on. Once that architecture is determined, you have to determine where to put it. And so let's just say that you're going to put a pod in place, and you want to run that somewhere, and you have that for your use case. Do you have the data center to run it on-prem?
That question is where strategy meets physics. And for most organizations, the answer is no.
More than 90% of the enterprise data centers do not have the capability today to run the next generation of gear that's coming out from the AI vendors. So they just don't. So they will need to build some new ones, which takes about 3 years, or they will need to buy and rent from a cloud provider of some sort.
90%. That's not a small gap. It's a fundamental mismatch between existing infrastructure and what's required. The research outlines these specific demands: high-density power delivery, advanced cooling, optimized layout, high-speed networking, high-performance storage, accelerated computing platforms. Each one represents a very real investment. Retrofitting seems like it should be an option. You've already got the building, right? You've got the power coming in. Just upgrade what's there.
Retrofitting, especially for some of the newer equipment, becomes challenging for a number of reasons. One is that you would need high amounts of power to the racks. And if you don't have that available to those racks, or you're going to try to rebuild it, that could be a substantial investment to go and try to change all the power to the racks is just a simple example. The other simple example is that most old data centers, or many, have raised floor. If you put a 3,000-pound super pod on a raised floor or try to move it, it may collapse that floor. And so those are some of the considerations simply for retrofitting that makes it a challenge.
3,000 pounds concentrated on a floor designed for a different era of computing. Different era. You can't optimize your way out of this. You either tear it out or the floor falls. It's the ultimate reality check for a strategy that only exists on a slide deck.
You're not benefiting the new environment by trying to retrofit. These are only going to require more power. They're only going to require, more space. They're only going to require different kinds of cooling. And so you're almost better off making $10, $15 million investment as an enterprise in a new data center space, because then you're able to really decide that you want to grow with it. And let's examine what the large co-locator providers are doing. So their investments are in making the next generation data center, not just for the next generation of NVIDIA gear, but the next one and the next. So let's just say we go to 1,000 kW racks, like the next one's 600 kW. It's going to go to 1,000 kW a rack. So density is super high in these areas. Well, in order for you to want to plan for the future, maybe you're building out the next generation data center to handle 200 kW a rack, right? I mean, those are the things that I think you have to be thinking about if you're one of these providers in the long run.
Design for the trajectory, not just for today. The catch is time.
The second side to that is that there's a timeline in getting equipment with this market when you're building a data center. That's always 18 months from a supply chain standpoint. So you and I could have several $1 billion and want to go build a data center, and it would not matter because the supply chain is what it is. So many companies that want to go build a data center will do it, but it'll take them 3 years.
If you're starting today, that facility isn't operational until 2029, which means the interim strategy, what you run, where, and on what, matters as much as that long-term plan.
So the enterprises are saying, yes, they want to do it. We're going to find land. We're going to go start building a data center. In the meantime, we need a strategy, a hybrid strategy for AI workload placement between now and then. And that could be a cloud mix. It could be a mix of on-prem that they might have existing to run air-cooled stuff that's older. Just kind of depends on what it is.
Hybrid strategy. Use what you have, lease what you need, build what's strategic. But all of that, of course, assumes something fundamental: access to power. And that assumption is increasingly fragile. Google has been quoted with 12-year interconnect timelines for electricity studies. 12 years just to complete the studies about connecting to the grid. The advancement of AI infrastructure is running headlong into the physical reality of power supply.
There are lots of different promises that are being made. People have this many megawatts they're going to build on. You hear brand new neo cloud providers come up and they're like, well, we've got this many megawatts coming online, followed by another 20 or 50 or 100. We don't know what's coming yet because the access to power is still such a challenge, and who's going to buy it all up?
For 30 years, we've told ourselves that cloud, it's everywhere. Geography is irrelevant, but physics is forcing us back to Earth. In the AI era, your most important strategic partner might not be a software vendor. It might be the power utility in Oklahoma or a gas reserve in Texas.
There's a lot of interest in those spots just by themselves. But the global scale of power and the requirements for power are going to drive some of this adoption. We are working with Australia as an example that actually has plenty of power. And so they have cheaper access to power. So if you can run your data workloads and your AI workloads in Australia, you might pay less money. The power piece to this is going to be something that we really have to take a hard look at over the next few years.
Available power capacity becomes strategic advantage. That's a different calculation than we've been making.
The other piece globally is the idea of sovereign data, which is super important. Data residing within your own country, within your own data center. There are not very many next generation data centers in a lot of countries around the world. Yeah. So the United States is clearly ahead in development of our data center spaces and how we're responding to the AI infrastructure that's required. The global market is the next big one, whether it's APAC or EMEA, because of the nature of that sovereign data center requirement. The data center builds globally are also going to increase pretty substantially.
Data sovereignty, combined with power constraints and 3-year build timelines, turns this into a national infrastructure issue, not just an enterprise IT decision.
I do believe this is the number one challenge we have with all AI is you have a place to run it that is got the power for it. And so next 3 to 5 years, we've got to keep our eye on the power.
So what does an organization actually do with this? The research outlines 6 steps: facilities assessment, high performance architecture design, efficient cooling, optimized rack layout, redundancy planning, and renewable energy exploration. Chris, well, he has a more practical starting point.
Most of the executives, I think, need to be thinking about a few things. One is what type of infrastructure is right-sized for your actual use case or your future use case? And then ultimately, what is the cost or the tokenomics around where you're going to put it? And those are checkboxes. If cloud is something you're used to and you're comfortable with throwing those to the cloud, great. You can send them to the cloud. If you want to use a neo cloud, that's one of the newer models that has more of the compute, but less of the managed part of it, you can certainly use those. I think these are all things and worth looking at. The TCOs are becoming a little more clear, with the on-prem being a little more expensive and the cloud being second most expensive and the neo cloud being the third most expensive. But once you start understanding what that looks like and those costs, that's the first part.
Understand the economics before you decide where to build. Then comes the facilities question.
If you want to go build a facility or consider a facility, I think a couple things. There's something called an AI data center readiness assessment. That is something we do all the time, and we actually attach one before any of these AI purchases that we make, because we want to make sure their data center is ready. We want to make sure that you can receive that gear and deploy it effectively. So much like that gear arriving on the dock we talked about earlier, we want to avoid the gear arriving on the dock.
Avoid the dock scenario. WWT won't sell you the equipment without doing that assessment first, because, well, they've seen what happens when you skip it.
The second side to that is if you're not ready, then let's take a look at what a data center would look like. Do you want to get the speed to market and use modular? Do you want to maybe use a colo facility in the meantime before you go build out? What are you looking to go build out, and how many megawatts are you going to need to be able to power that data center? So these are all the questions that I think need to be looked at over anybody looking at facilities and determining how they want to move forward with their AI projects.
Those questions lead to actual decisions, not planning exercises, real choices about workload placement over the next 3 years while long-term capacity comes online. There's also a skills dimension that really doesn't get enough attention.
High performance compute, which is AI compute, is wildly different than traditional compute. The folks running the high performance compute data centers and the AI data centers are going to need different skills to be able to do that. You're also going to need, if you're a data center person, how are you going to go rack and stack some of this gear if it's never been done before? The cabling is a lot different than what you're used to. All of these things require new sets of skills. So either you're an existing person in traditional data center world or facilities world, you better learn the new stuff, or you're pivoting because maybe your area is something that is getting less emphasized through budgets or through importance in the AI technology stack. Looking toward the high performance compute data center type world is a future.
That pivot opportunity is real. Chris even tells people working for power utilities to get on AI teams. These projects need that expertise. The WWT AI Proving Ground is a resource specifically designed for this moment. $500 million invested in reference architectures and vendor gear.
2 years ago, we invested $500 million in an extension of the ATC called the AI Proving Ground. We have 17 or 18 different reference architectures from NVIDIA and others in there. We have every vendor you would want. It's a playground for folks to go and try proof of values, proof of concepts. So our clients use it all the time. It's certainly used a lot. We're going to invest more in that space. That's a tremendous tool that our clients use.
Chris Campbell has seen the Blackwell pod sitting idle on loading docks. It's a quiet, expensive reminder that enthusiasm is not a substitute for infrastructure. The math is simple but brutal. It takes 3 years to build a new data center, but only 3 minutes to order hardware you can't actually plug in. The interim strategy isn't just a bridge, it's your survival plan for the next 1,000 days. Use the proving ground, do the assessment, because the only thing more expensive than missing the AI wave is catching it and having nowhere to land.
We are at the beginning of an AI journey. It's not the first mile of a marathon because the marathon doesn't end. We are constantly evolving. And so embracing change is the number one thing I tell clients. The old ways are great, but over the next 5 years, we have to embrace the new ways to do things, including using agents and AI to work more effectively.
Embrace change as an operational discipline. But remember, physics doesn't negotiate. The Data Center Priorities Research is available right now at WWT.com. Priority 3 walks you through the actual 6-step framework for AI-ready infrastructure, from the initial facilities assessment through to renewable energy planning. If you're looking to avoid the loading dock scenario, this paper is a great place to start. I'm Rob Boyd. Thanks for watching.
This episode is supported by Graphiant. Graphiant offers next-generation networking solutions that simplify and secure enterprise connectivity. Experience seamless network management with Graphiant's innovative platform.